Well, hello. We're going to be working with logarithms, and I can't say it enough. A logarithm is an exponent. Although I have to say when I was a student I didn't understand that right away, but it really is. So let's review a law of exponents. When you multiply like bases, like I'm doing right now, x to the 3 times x to the 2, you add the powers, 3 plus 2. When you multiply like bases, you add the exponents. So that will give you x to the 5. So it stands to reason that if you're taking the logarithm of a product, you're going to break it apart into a sum. You're going to add. That's precisely what we're going to do. Log base 8 of 5 plus log base 8 of w. Okay, let's move on. Now, another rule of exponents, property of exponents, if you have a base and you raise it to a power, and you raise it to a power again, you multiply the powers. So this would be x to the 3 raised to the 2 would be x to the 6. So it stands to reason then that I would multiply, and how I'm going to multiply is I take this power down in front like that. So this is going to equal negative 6 times the log base c of z. These are rules you're going to have to pretty well memorize. Okay, the ln is log base e, and what we're dealing with here is the ln of the 6th root of 3. But what is the 6th root of 3? The 6th root of 3 is just 3 to the 1/6 power. So I'm going to take ln of 3 to the 1/6 power. But now that I have a power, I take that down in front and multiply. So this is going to be 1/6 times the ln of 3. Next. That scratching is my cat in her litter box. How delightful. Okay, remember the property of exponents. When you divide like bases, you subtract the exponents. So this would give you x to the 3 minus 2, which would be x to the 1. Okay, well that's precisely what we're going to do here. I have log base r of b over 6. That means I'm going to have log base r of b minus log base r of 6. All right, now we're going to get down to business on some of this stuff. All right, I have a product here. I have log base b of parentheses x to the 3rd, y to the 4th, z. So this is what we do. This will be, in a couple of steps, log base b of x cubed plus log base b of y to the 4th plus log base b of z. Now I'm not done, but this is where I am during this step. Now in the next step I'm going to take my exponents and put them down in front. I suppose you could put two steps together. I like to do it separately because it's much more orderly that way. Suppose it's a little OCD also. So I'll have 3 log base b of x plus 4 log base b of y plus log base b of z. One step at a time, this stuff is not so bad. Here we have the ln of 6 over 5 x to the 5th power y. So I'm going to take the ln of 6 minus the ln of, parentheses, 5 x to the 5th y. That will give me the ln of 6 minus, minus, parentheses, the ln of 5 plus the ln of x to the 5th plus the ln of y, parentheses closed. I did that because this is one statement, the ln of parentheses 5x to the 5th y. Okay, so I need to handle that separately. Now I'm going to acknowledge that I'm subtracting. So I'll have the ln of 6 minus the ln of 5 minus 5 ln x minus ln y. Okay. Now, we've been taking logarithms apart. We're going to start putting them back together. I have log of 1 million minus log of 100,000. That means I have log of 1 million over 100,000. The zeros are tens and they cancel, and I'm left with the log of 10. Now, let's stop and analyze. When you just see the word log, its base is 10. And what a logarithm is tell me what the power is that the base 10 is raised to so that I can get a 10. And the answer, of course, would be 1. 1 is the exponent that the base is raised to get what's called the argument of the function, because 10 to the 1 equals 10. Do you see how a logarithm is really an exponent? It's the exponent that the base is raised to so that you can get the argument of the logarithm function.